Hello and welcome back. And in this video, we're going to be taking a look at another classic stack-related interview question. And this one is evaluating reverse Polish notation. So essentially, the problem states that you have been given an arithmetic expression in reverse Polish notation. All right, and the valid operators are just these. So they're limiting the scope of valid operators with plus, minus, multiplication, and division. So addition, subtraction, multiplication, and division. Now each operand may be an integer or one of these expressions. Okay, and the expression given is going to be always valid, so it's not going to be an invalid expression. And we should always evaluate to a result. So there's not going to be a case where you're not going to get any result. So the expression is going to be evaluated to a result, and there won't be any divide by zero operations. So that's your problem. And for example, the example input is you've been given 2, 1, plus 3, and star. So the way reverse Polish notation goes is basically how calculator operates. Is how calculator calculates the values without using the without getting into operator precedence and without having those brackets and stuff like that. So this is how it does. Basically, you have two of the integers, for example, and those are called operands, and then you have an operator. So when you encounter these operands, right, and as soon as you encounter an operator, you actually apply that operator into these operands. So for example, 2 and 1, and then plus encounter, so you're going to add 2 and 1, and you're going to make it 3, and you're going to put 3 in place. Okay, and you never insert, so basically, you never insert a operator. So I'm kind of like walking into the solution, but I'll try to stay away so you can actually try it on your own. But anyways, yeah. So you got 3, and then you have another 3. So you have 3 and 3, and then you have multiplication. So 3 times 3 is 9. All right. So that's how you calculate, and this is how it looks with the brackets in order to see how it operates. So you have 2 and 1, and there's addition between that, and then you get 3 from there, and you have multiplication, and you get 3 times 3, and you get 9. Okay. Another example, we have 4, 13, and 5. As you can see, 5 and 13. Right after that, there is the operator. So you do 13 divided by 5, and then whatever you get, you actually add it to 4. So you get 2 here because these are integer evaluations. So 5 times 2, 10. So whatever remainder is there, you just drop it and you just say 2 because it's the integer part, it's not fractional part. So you get 2 here, and then you add 4 to 2, you get 6, like here. Okay. So similarly, this is like rather a long expression, but yeah, you get the idea. So I would actually recommend taking a pause here. We have touched upon like the logic a little bit, so what you're gonna have to do. So take a pause and try to come up with a potential algorithm for this one, and then resume the video to see what we've got for you. All right, so hope that went well. Let's go ahead and take a look what we have got for you. So what we're going to do is we will first try to create a function, reverse Polish or RPN. It's called RPN. And it's going to take an array, string array as the input, and going to return an integer as output. Okay, so what we're going to do is we can create a stack, right? And we can create an integer stack. Okay, and for each item, what we're going to do is basically we're going to loop over, right, each character or each item in the array. And what we're going to do is sorry about that. What we're going to do is we will take each analyze each item in the array. So let's say it's 2. If it's a number, we're going to push it into the stack, right? So we're going to push 2, and we're going to push 1. As soon as we encounter an operator, we're going to pop these out. So we're going to pop 1 out and 2 out, and then we're going to do 2 plus 1. Okay, and then we're going to result, we're going to push back into the stack, and that becomes 3. So then we have 3 and 3, and then we got multiplication. So basically, we pop 3 and 3 out, multiply them, and we got our result. Final result, we push it into the stack, and we remove as a return item. We actually return the last item that's there, basically in the stack, or we pop the stack, and that is going to be our solution. Okay, so let's take a look. So we're going to say char and or SNARR, so whatever the element is or item. This will make more sense. All right, so first thing we're going to do, we're going to say if let. So we're going to try to convert this into an integer. So that way we would know if our item is an integer. If we are able to, then we're simply going to say stack.append that number that we have evaluated. If that's not the case, then we are into a situation where we have operator. So we are at plus in this example. So in that case, we're going to simply say first element and stack dot remove last, okay, and second element stack dot remove last, okay. Now we're going to put a switch statement on that item, and we're going to say case. We're going to take all those cases, so plus and minus multiplication and your division, okay? And all of these are going to do the same operation. We're going to say stack dot append, right? And whatever we calculate. So we're going to say stack dot append second element plus first element. And you're going to take that operation, just make it subtraction, make this one as multiplication, and make this one as division, okay? And at the end, we're going to return our stack dot remove last. There we go. Okay, so so if we are doing all these, we are writing second element as first. So reason is this is going to be your first element because this was your last element, right? So this is going to come out as first element, and this is going to come out as second element. So you can do 2 plus 1, and this order is going to matter on the division side, which is why we always consider the second item and add to it or subtract from it, multiply to it, or divide to it. Okay. So with that, let's test it out. So I'm going to say let input, and let's put some of these values in there. So I'm going to take all these values from the slide. Okay, and we can say for I and p print RNP. Hi. Okay, so let's go ahead and run this, and we made a mistake. Okay, not having default case, because default is always needed for a switch. Fatal error. we should never see this. Okay. All right. So what we are missing, R and P. Okay, RPN. That's my bad. All right, let's try it one more time. There we go. So we have 9, 16, and 22. If you take a look at 9, 6 and 22. Sorry, did I read it wrong? 9, 6, and 22. Yeah, I read it wrong. And if you take a look at our stack, so if you print our stack, you're gonna notice how our stack actually builds up. So you get 2 when you insert 2, you get 1 when you insert 1, and when you get to the operator, then you actually pop that out, and then you pop that back in, right? So 3 and 3, and then you apply the next operator on that, and you actually return the end statement. I mean, the last element from the stack, and similarly, like you follow the same operation. As you can see, this is how your stack is going to be able to resolve your reverse Polish notation problem. All right. So yeah, so that was it for this video. I hope you guys enjoyed this video. I would recommend once again going through the algorithm and looking at each statement carefully to understand. But this is actually one of the simple problems there is related to stack. So hope you guys enjoyed this video, and thanks again for watching. I'll see you guys in the next video.